So for the video today, what I'm going to do is I'm going to walk you through how to solve the following problem. Your goal is to find the acceleration of the system. We have two blocks. One of them has a mass of 20, the other 15. We have a coefficient of kinetic friction of 0.25 between block A and the ramp's at a 20-degree incline. So what I'm going to do is I'm going to go ahead and start by drawing a free body diagram. So I'll do free body diagram of block A. We're going to have mg down because gravity exists and we're on Earth, so it's mg down. Normal force, that'll be perpendicular to the ramp. We'll have the force of tension that's going to follow along the rope, and our force of friction that will oppose the force of tension. So let's take a look at the sum of forces that are acting on block A. So the x and y direction, I'm actually not going to use x and y, I'm going to use direction of motion and perpendicular direction like we had talked about in class. So the d of m and the perpendicular. The d of m, to give everyone a clear idea, the direction of motion is following this way for the problem. So anything that moves in this path will be considered positive. The direction of motion for column 4, block A, we have tension is positive, friction is negative, and then mg sine theta, and that equals ma. In the perpendicular realm, it will be normal force minus mg cosine theta equals 0. So the normal force can be simplified to say it equals mg cosine theta. We'll plug in the 20, the 9.81, and the cosine of 20 degrees, and we can directly solve for the normal force. We will need that later because friction depends on the normal force. So punch in the calculator, 20 by 9.81 by the cosine of 20 degrees. I get 184. So that is our force of normal. If I come back over here, I can say the force of tension minus friction, which is mu Fn minus mg sine theta equals ma. Let's go ahead and plug in some numbers and see what we get. So let me get this free body diagram out of the way. Move that over here. So the force of tension minus the coefficient, which is 0.25, times the normal force, which we just solved, would be 184, minus 20, 9.81, sine of 20 degrees. This is a very long line. Continue to move it over here. That will equal the mass of A, which is 20, times A. So do some mathematics and simplify this. This will be 46.1. 20 by 9.1 by sine of 20 degrees is going to be 67.1. That equals 20A. So we simplify the force of tension minus 113.2 equals 20A. Excuse me. So that's as far as I can get. We're looking at block A. So let's go back and look at block B. So block B is much simpler, only two forces, mg and tension. So the sum of forces on B equals ma. Now the way direction of motion works, mg is going to be positive if we follow the blue arrow. So it'll be mg minus the force of tension equals ma. So 15, 9.81 minus the force of tension equals 15a. So we'll have 147 minus force of tension equals 15a. So at this point, right now, I have two equations. Whoops. One of them is here, and the other one is here. Now, the way tension works is tension is going to be uniform throughout the rope, so those two tensions are equal. And the whole system has to accelerate at the same rate, so that acceleration for both of these blocks also has to be equal. So what I'll do is I'll solve this one right here. Excuse me for 1 second. Sorry about that. I had to pause the video to sneeze. As I left off, what we'll do is we'll solve for the force of tension from this equation here. So I get 147 minus 15a equals the force of tension. I'll plug that in for the force of tension here. So 147 minus 15a minus 113.2 equals 20a. I'll move the a's to the same side of the equation. In doing so, I'm going to end up with 33.8 equals 35a. And we see we're going to have a pretty gentle acceleration. The acceleration I saw for was 0.966 meters per second squared. From here, the problem could mix back into kinematics. For example, it could say if block B falls 2 meters, what was the time required to do that? So now our force problem has become a kinematics problem. Delta y would be -2 meters. Whoops. V initial would be 0. The acceleration, which is downwards, I'm going to make it negative now. 0.966 meters per second squared. I can use the second equation. Delta y is v naught t plus 1/2 at squared. This cancels out. -2 equals 1/2 times a negative 0.966 t squared. Solve t. And I got 2.03. Alrighty, enjoy.